2. Here's our first example. I don't want you to write this down. I just want you to walk through it. So sometimes our unit circle can benefit us to find the half angle exact values. So we want to find the exact value for the cosine of 15 degrees. If you look at your unit circle here, 15 degrees is halfway between 30 degrees. So here's 15 degrees right here. And we want to find the exact value for the cosine. What is that x value? And it's not there. So what we can do is we can double it. Double the angle. So the double of this angle is 30 degrees. Is 30 degrees on our unit circle? Yes. So then what we're going to do is we're going to use the half angle formula. So if we go back, we're using this formula right here. And we're going to substitute it in. So here is the square root of 1 plus the cosine of 30 degrees over 2. And then what you do is you substitute in that 30 degrees cosine. So you get square root of 3 over 2. And then the rest of this problem, they're not really showing all the simplifying down. We're going to do that in the next sets of problems. All right, so here's what I do want you to write down. We want you to find the exact value for the sine of 105 degrees. So if we look at our 105 degrees, I'll do this in red. There's about 105 degrees. Notice it's not on the unit circle, but we want to find the exact angle. So we want to ask ourselves, what is the double of 105 degrees? So we're going to take 105 and multiply it times 2. So multiply it times 2 to get the double, and you get 210 degrees. So the double of 105 degrees is 210. So if you notice down here, here's 210 degrees. We have that on our unit circle. So now we're going to choose the appropriate formula. In this case, our sine is right here. And we're going to say the sine of 210 degrees over 2, which is 105 degrees, square root, I'm going to talk about the plus or minus in just a minute, 1 minus the cosine of 210. Be careful there that you're doing 210, not 105. Now, our angle is in the second quadrant, right here. So for every sign in that second quadrant, it has to be a positive. So when they say plus or minus here, you have to be careful what quadrant this angle falls in. So it's going to be a positive sign. All right. Now what we're going to do is we're going to simplify this equation. All right, the cosine of 210 degrees, we need that number. So if you look at the cosine is your x value, so negative square root of 3 over 2. We're going to substitute that in just a moment. So it's 1 minus, we're going to replace that cosine of 210 with its value, exact value of negative square root of 3 over 2, and then divide it by 2. Now the rest is simplifying that. So I'm going to change this 1 to a 2 over 2. And then I have a negative, negative, turns that to a positive, and then square root of 3 over 2. So what I'm trying to do is clean up that numerator, those two fractions. Now I have 2 plus the square root of 3 over 2 divided by 2. Now I have 2 plus the square root of 3 over 2. I'm going to change this division symbol to multiplication, and then I'm going to change this denominator to a reciprocal of 1/2. And then we're going to multiply across. 2 plus the square root of 3 over 4. The last thing we're going to do is we're going to just change that to two separate radicals. One in the numerator 1 in the denominator, because the nice thing with that square root of 4 in the denominator can become a 2. So there is the exact value for the sine of 105 degrees. All right, let's do a second example now, but now we're changing it to radian measure. We want you to find the cosine of pi over 12. So if I graph pi over 12, pi over 12 is halfway to pi over 6. So here's my angle, theta, pi over 12. So we're going to ask ourselves the same question. What is the double of pi over 12? Well, if you double it, you're going to get pi over 6. And I'll show you how to do that. So you take pi over 12, and again, we multiply it by 2 like we did in the last example. So we multiply across 2 pi over 12, and then reduce it by 2, and we get pi over 6. So the double of pi over 12 is pi over 6. All right, now everything in the first quadrant, since this angle falls in the first quadrant, cosine will always be positive. So now we're going to choose the appropriate formula. Since we're asking for the cosine of pi over 12, we're going to choose this second formula, which is circled, and it's going to be a positive because it falls in the first quadrant. All right, so the cosine of pi over 12 equals the square root of 1 plus the cosine of, remember we're using pi over 6, not pi over 12. We're using the half angle formula. Now we are going to look back over here. Our cosine for pi over 6 is square root of 3 over 2. So we'll plug that in for our cosine value, and then we'll leave everything else the same. 1 plus, and then the rest is simplify all the way down. So I'm changing that 1 to a 2/2. So I can combine those two fractions together in the numerator. 2 plus 3 over 2 divided by 2. 2 plus the square root of 3 divided by 2. I'm going to change this to multiplication and flip that denominator. Now we multiply across. We get 2 plus the square root of 3 over 4. Remember, like the last example, we separated out the numerator into a separate radical, and then the denominator into a separate radical. Square root of 4 in the denominator is 2. So there's our final answer for the cosine of pi over 12.